Hello, and welcome to the 3.5 Day 2 video. This is the last of the new material for this unit, so let's get started. This video is going to be all about looking at a graph and writing the equation. So if we scroll, we can see here's our graph at the bottom of the page. This is page 8 in your blank notes if you're taking a look. Things we're going to want to take a look for, any x-intercepts. We're going to want to take a look at our asymptotes, any holes, and then we'll set up our equation, and then we'll use our given point to plug in and solve for the a value, just like what we did for polynomials. So first, we're going to be taking a look at our x-intercepts. We happen to have one right here at x is equal to 2. So I'm going to write that up here. So for my zeros, we have one at x is equal to 2. Now, if I take a look at my first bullet point, it says state any zeros, which we just did. Use these to determine factors and the multiplicities. So the factor for this is when we try to set this equal to 0. So if I subtract 2 on both sides, I can say that my factor for this is x minus 2. And then I want to take a look at the multiplicities. So again, back to our polynomials, if I take a look, I can see, oh look, right here, it bounces off that x-axis. So since it bounces off, that is going to be a multiplicity of 2. Now remember, this goes for the numerator. So all this information right here, our x-intercepts or our horizontal intercepts, are for the numerator. So our numerator, we're good. Next, we're going to look at our vertical asymptotes. So for our vertical asymptotes, we happen to have 2. We have one here when x is equal to 1, and we have another one here when x is equal to 3. So let's write that down. So for our vertical asymptote, we have x is equal to 1, and x is equal to 3. And just like what we did with the previous problem, we're going to state any vertical asymptotes, and then use these to determine the factors and the multiplicities. So the factors here, again, I'm going to try to get these set equal to 0. So in this case, we're going to have multiple factors. We'll have x minus 1 and x minus 3. And then it asks us for the multiplicities here. Now, what does a multiplicity of an asymptote look like? Well, this goes back to the 3.4 video with our two different parent functions. One of them was 1 over x, the other was 1 over x squared. So we're going to say, and I'll do this in green, if we have an odd multiplicity, for a vertical asymptote, it's when the graph, it's when it kind of looks like that 1 over x graph that we have. So that if we have an asymptote, my ends are going in opposite directions. So it's going to look something like this. Oops. Or like this. So this is what you're going to see most of the time. Now for an even multiplicity, there's so many I's in that word. Okay. For vertical asymptote, when you're looking at a graph, that's going to look more like the graph of 1 over x squared, where both of our ends were going in the same direction. So if this is my asymptote, both of my arrows might be going up, or both of my arrows might be going down. So we have to look around each of the asymptotes to determine these specific functions. So if we take a look, I'm going to highlight some stuff. So I take a look here at my first asymptote, and I see, okay, those two purple ends, they're going in opposite directions. It looks a little bit like this version up here, so that's going to be an odd multiplicity. For us, that's going to be a multiplicity of 1. Oops, that's still in yellow. I meant for that to be in black. It's going to be a multiplicity of 1. And then we're going to look again at the other vertical asymptote, and I see, okay, this looks a little bit more like this right here. So it's still an odd multiplicity. The ends are just going in the other than the opposite ways. So for us, odd multiplicity is going to be 1. Again, meant to do that in black. Is going to be 1, and even multiplicity for us is going to be 2. So when we're dealing with our vertical asymptotes, we're only ever going to be dealing with multiplicities of 1 and 2. And all of this information here is going to give us our denominator. So again, all of this right here gives us our denominator. Now, bullet number 3 is not always going to be applicable. It's dealing with a whole. So if there's a whole, we're going to set x equal to whatever that value is, then put it in a factor in both the numerator and the denominator, since that's where a whole comes from. So this is your numerator, this is your denominator, and then a whole might be added to each of those. And the way I'm going to identify a whole is if I see a physical open point in the graph. So if I take a look at our graph, and I go, okay, all good, I don't see any physical open points, we can say holes. There are none. Okay, so if that's the case, then we're going to do the very last step and use one other point to determine if there's a constant factor other than 1. So this is where we set up our equation, plug in our point, and solve. So let's get going. Here we go. Oh, I did not leave myself a ton of space. That's okay. So when we set up our equation, we'll have, maybe write kind of small, r of x is equal to some a value. We don't know what the a value is. And then I have to put in my numerator. So for my numerator, I know that we have a factor of x minus 2, and that's going to have a multiplicity of 2. And then in our denominator, I know we're going to have the factors of x minus 1 and x minus 3, both with a multiplicity of 1. So this is our setup. Now I'm going to take our point of 0 and 8/3. We're going to use, I'm going to zoom in here so I have enough space. We're going to use 8/3 for our y value. And we're going to use 0 everywhere we see an x. Oops. 2 squared. 0 minus 1 times 0 minus 3. Okay, so from here, we're going to solve it. I'm sorry that this looks so funny. I just did not leave myself enough space. So let's see. We'll have 8/3. Oh, my goodness. I don't know what just happened. Reset. Okay, I'm going to pause because I don't know what happened. All right, well, I think my hand just pressed a button and I figured it out. Anyway, sorry. So we have 8/3 is equal, oh my god, I did it again. Okay, I don't know if it likes me zooming in this much. We're just gonna keep go, oh my, okay. Oh, you know what? I think it hit the, I'm not gonna edit any of this out. I can get back to the pen. Did we do it? Yeah, okay, I think I just had my arrow on the zoom in button. Okay, so 8/3 is equal to a times -2 squared over -1 times -3. And that is going to be 8/3 is equal to a 4a over -1 times -3, which is 3. So since I'm dividing by 3 on both sides, I can just multiply both sides by 3, and I get, I'll just continue over here. 8 is equal to 4a, and then I'm going to divide both sides by 4, and I get that my a value is 2. But again, I'm not going to stop here. I'm going to rewrite my final equation. So my final equation is going to be r of x is equal to 2 times x minus 2 squared over x minus 1 times x minus 3. So you're building your numerator, you're building your denominator, you're finding that a value. Excellent. Let's go on to our next problem, and hopefully I'll leave myself enough space this time. So let's take a look at example number 9. So down here we're going to look, first we have to start with our numerator. So we're going to look to see if there's any x-intercepts or horizontal intercepts. So I look here and I'm like, well, it's getting pretty close to 0, getting pretty close to 0. I don't actually see any horizontal intercepts. And sometimes you don't, and that's okay. So we're going to go back up to the top, and we're going to say zeros, none. And sometimes that happens. So it means you're either just going to have your A value in the numerator, or if you find any holes, they'll be included in that as well. So let's get moving on to our denominator, taking a look at our vertical asymptotes. So let's see, we have 2 vertical asymptotes. We have one when x is equal to -4, and we have one when x is equal to 2. So that's x is equal to -4 and x is equal to 2. So if I'm going to write that into factors, how that's going to look in our equation, I'm going to add 4 to both sides, so it'll be x plus 4 and x minus 2. And now let's look at the multiplicities. So if I take a look at that very first one right here where x is equal to 4, I see that both of my ends are facing in opposite directions. So for us, that's going to be a multiplicity of 1. But if I take a look at that second asymptote when x is equal to 2, I take a look at this and I go, oh, you know what? Both of my arrows here are facing the same direction. So since they're facing the same direction, we're going to call that an even multiplicity and say that this vertical asymptote has a multiplicity of 2. So that's kind of the difference, and that's how we identify them. So remember, this is all towards our denominator. And let's go back and take a look at our graph. We're looking for holes. I don't see any open points on this graph. So holes, we've got none. All right, so let's set up this equation to the best of our ability. Okay, so we're gonna have r of x is equal to, we don't really have anything for our numerator. We don't have any zeros. So we're just gonna have an a on top, because we don't have any x-intercepts or horizontal intercepts to include out there. And then in our denominator, we have a factor of x plus 4 that had a multiplicity of 1. And then we had a factor of x minus 2, and that had a multiplicity of 2. Please do not forget your multiplicities. That's going to make a difference. All right, so here's our setup of the equation. We are going to be using the point 0, 1 in our equation to find our a value. So we're going to plug in 1 for our y, and we are going to plug in 0 everywhere that we see an x. All right, let's get to solving. So we're going to have 1 is equal to our a value over 4 times -2 squared. 1 is equal to a over 4 times a positive 4. So 1 is equal to a over 16. So to get rid of this fraction, I'm going to multiply by 16 on both sides. And I just get that my a value is equal to 16. So when I write out my final equation, I'll say that r of x is equal to 16 over x plus 4 times x minus 2 squared. And that is our final equation. So I want to just go over one more problem with you, even though I know it's not in your notes packet, just because I wanted you to see what it looks like when you're writing an equation like this and there's a hole in the function. So I have a graph just below here. We're going to be going through the same type of features. We're going to be finding our numerator, our denominator, as well as finding our holes and then setting up the equation. If you want me to send this picture to you, I can. You can also just either take a picture of it yourself, rough sketch it, anything like that. So the first thing we're going to do is we're going to look for our x-intercepts or our horizontal intercepts, and I see that we have 2 of them. So let's see, so for us, our zeros, we've got 2, we've got 1 right here and 1 right here. And I know this one looks a little weird. They are both actually going straight through. We don't have any multiplicities of 3 here. So let's see, this is going to be, there we go, at x is equal to -1. Oh, pardon me, no, -3. And at x is equal to 1. And then when we write out our factors, we're going to have x plus 3 and x minus 1. There's the x minus 1. And then, like I just said, for our multiplicities, those are both going straight through. So this is what we want for our numerator. And then for our denominator, we're going to look at our asymptotes. So for our asymptotes, where's my pen? We have two asymptotes. We have one here at x is equal to -2 and one here at x is equal to 4. So the factors for this would become x plus 2 and x minus 4. And when I take a look at these asymptotes, I see here both of my ends are facing separate directions, and here both of my ends are facing separate directions, which means both of these asymptotes are going to have a multiplicity of 1. And this goes towards our denominator. And now we finally have an opportunity to look at a whole. So for us, when we look at our whole, we're not going to have a multiplicity on a whole since it's just a point, but we can take a look at our vertical, or probably not a vertical asymptote, the x value that we're going to have there. So for us, this is going to be x is equal to, right here, so this is, we have our whole or our physical open point when x is equal to 0. And then for this, we would also find a factor. So you can subtract or add 0 on both sides. So if you want to have a factor of x plus 0 like this, you can do that. Or since it's already set equal to 0, you can just leave it as x. Now remember, this goes in both the numerator and the denominator. That's where it's found. So when we write up our Mach equation, it's going to look like r of x is equal to some a value times our whole, don't forget your whole, times x plus 3 times x minus 1, since those are our zeros or our x-intercepts, both having a multiplicity of 1, divided by x, since that's our whole, times x plus 2 times x minus 4. Those are vertical asymptotes, or the factors of those, both with a multiplicity of 1. And it's not particularly listed on here, but we're going to be using this point right here as our plug-in section, and this is the point -1 4/5. So I'm going to plug I'm going to plug 4/5 in for my y value, and then anywhere I see an x, I'm going to plug in -1. Thank you for sticking with me as I change all of the colors. Okay, parentheses. Okay, I'm going to shift. So this is all of our information. So let's start solving. So we're going to have 4/5 is equal to a times -1 times 2 times -2 divided by, whoops, I did that thing again, -1 times 1 times -5. Let's see, 4/5 is equal to, see in our numerator, this will be 4a. In our denominator, that will be 5. So I can multiply both sides by 5 and get 4 is equal to 4a. and then I can divide both sides by 4, and I can get a is equal to 1. So when I write up my final equation, I can say that r of x is equal to x times x plus 3 times x minus 1 divided by x times x plus 2 times x minus 4. So showing this shows that there is a value of 1. If you want to write a 1 in there, you can do that. But if you just give me this information and you don't show me using your work to find your a value of 1, I will mark you down for that. But anyway, this is the last of the brand new information from our rational functions unit. Let me know if you have any questions, and I look forward to seeing you tomorrow.